Hello everyone, my name is Biao. I come from Zhengzhou University in China. Thank you for giving me a chance to show my work. WiMPP, an indoor multi-position positioning method based on Wi-Fi signal. I will introduce this paper from 4 parts. The first part is the introduction, which mainly introduces related technologies and characteristics, as well as the contribution of this paper. Then there is the system structure, which mainly explains the components and the function realization of this positioning system. The third part is experiment and evaluation, which mainly introduces the experimental environment and evaluation standards used in this article. The last part is a conclusion. Look at the first part. Indoor positioning technologies, mainly including computer vision, spatial sensors, and wireless sensing technologies. Computer vision technology has high recognition accuracy and a wide range of applications, but its shortcomings are also obvious. It's easily affected by light and obstacles, and violates user privacy. Spatial sensor technology uses spatial sensors or wearable devices to collect the motion information of human body contained in the signal, so as to realize the perception of the position of human body. They can achieve fine-grained activity perception with high precision, but this signal need to be high sensitive and accuracy in positioning or being worn by the moderate target. In recent years, indoor positioning has been extensively studied because of the unique characteristics of long-distance, non-contact, and resistance to camouflage. Indoor positioning technology using wireless networks has received widespread attention, and Wi-Fi is widely used in wireless sensing technology because of its high coverage rate and low deployment cost. Using location fingerprints for positioning requires a lot of extra overhead, and other methods must require multiple sets of wireless devices to implement. How to achieve high-precision indoor positioning with few computer resources are deployed is a challenge. Now, I will introduce the main contribution of this paper. In this paper, we proposed a two-person indoor positioning method. The heat map is generated by two-dimensional multi-signal classification arguing estimation angle of arrival and time of flight parameters, and then a convolutional neural network is constructed to classify the generated heat map to achieve positioning. and a new model is proposed, which puts a heat map containing position information parameters into our model to achieve positioning. We have also established an indoor positioning dataset based on Wi-Fi signals. Wi-Fi devices collect location data from volunteers of different gender, age, height, and weight. A two-person indoor positioning based on deep learning is proposed, with an average distance error of 6 centimeters and a median distance error of 8 centimeters. The second part introduces the system structure. The figure shows the structure of system, including data processing module, deep feature extraction module, and the classification module. Collection module. The system established a Wi-Fi monitoring environment through the transmitter and receiver, and collections CSI data of different volunteers in the area. Data processing module uses the music algorithm to extract the location information in the original CSI data and convert it into a heat map. Classification module. The classification module trains neural networks according to different heat maps corresponding to different positions targets in an area, as shown in the figure. The Wi-Fi transmitter and receiver are located on one side of the area. The Wi-Fi signal in the area is carried and reflected to the people and objects in the area. When these signals reach the receiver, they implicitly contain information about the people and objects interacting with them on the path from the transmitter to the receiver. And these signals can be used to infer the location of targets in the area. In data collection module, what we have to do is to collect the location information of different targets in the area. After collecting the signal that containing the target's location information, we use the music algorithm to extract the location information. Through two-dimensional signal analysis, the spatial spectrum function is constructed. Then, by searching the spectrum peaks, the target's positioning parameters, the angle of arrival and time of flight are obtained. In classification module, we built a new network model to obtain positioning. We improved the inception module. Not only used residual links on its basis, and added the underlying features to the subsequent operations, and use 1 multiply 1 convolution instead of the concatenate layer to linearly combine features of different scalars. The model can reach deeper and have better feature extraction capabilities. so as to achieve better positioning factors. The third part introduces experiments and model evaluation. The related contents of data collection are introduced. We use one transmit and one receive. Receiver has 3 antennas, each receiving 30 subrequests. We collect a total of 2,000 pieces of data from different positions, in the case of 2 persons from an empty laboratory. We divide the indoor detection procession into 20 squares, and each target stands in a square when collecting data. The positions of the 2 targets don't overlap each other. Therefore, each piece of data contains the location information of the 2 targets. The collected dataset is divided into test set and training set. In addition, we also collected a dataset when the target was moving. The movement here mainly refers to moving from one labeled square to another. This dataset is used to observe the impact on target positioning when the target moves. In this paper, we use average distance error, median distance error, and cumulative distribution function diagram as application criteria. In order to verify the performance of our proposed model, we compared the results of our model through average distance error, median distance error, parameters, and duration, as shown in the figure and table. It can be seen from the table and figure that our model has better performance in terms of positioning accuracy and running time. In the last part, the following is a summary of our work. Facing the last challenges of current research on multi-position indoor positioning, we proposed a double target indoor positioning method in this paper. This method only uses a pair of transceivers for seizing and can achieve good positioning results. The new network model we put forward in this paper can not only better extract the location features of the targets, but also solve the features degradation problem more effectively, which is also the basis for this method to achieve good positioning results. Comparing the method in this paper with the most advanced deep learning method for indoor positioning, the positioning error of our proposed method is smaller. The future goal is to achieve multi-position positioning with more than 2%, to achieve target trajectory tracking, and to further enhance the practical view of indoor positioning under Wi-Fi signals. My introduction is over. Thank you.